Hello everyone, I am Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. And this video today is a homework example brought to life when it comes to status flags, data-related operators, indirect addressing, jumps, loops, and so much more. Everything there is to do up to, but not including if statements and loops, like loop loops, not these kind of loops that we've been so far. So here is the problem. Basically, this is just a big loop that prints the numbers from 3 all the way up to 30, inclusive on both ends, counting by 3 every time. And so here is the C++ example, which you could run through IDE 1 or Visual Studio or any compiler at any time, and you could see the basically what you're supposed to get for your output. Okay, so when it comes to the data itself, I can see here that I'm supposed to have an int, and it's supposed to be called value. And int is a signed double word, and then its value is supposed to be 3. So that brings me over to just finishing up the only data member that is supposed, global variable that's supposed to be part of it. Bring this a second here so I can, list. And what I do, oh shoot, void main here. Get rid of all that stuff. This is what the code is supposed to be doing here. And okay, so here we go. So now we're ready to push on and do the meat of this thing. So this just says take ECX, and again, when it comes to C++ to assembly language, there is no comparison because you can't just use the registers directly in C++. You are removed from that. That's what high-level languages do. But if I want to, say ECX is equal to 10, I just move 10 into the ECX register. And this do, what is the do, what is the while? And here I've set this up again to be exactly what the loop operation does, because it says the loop operation decrements the ECX register and then does a 0 check. And if it is 0, it falls through and the loop ends. And if it's not 0, it goes back up to the top. So just what is the analog for this in assembly languages? The do part of this and the open curly brace kind of starts a label, which I usually call again until I can't do that anymore. And then this guy here is a loop statement that goes loop again. And since I initialized the ECX register outside of the loop, only this loop statement will modify it. So it'll go from 10 to 9 to 8, 7 down, down to 0 before it falls. And so that covers the loop part of this. And let's see, here's the cout here. This is just a call, I do an endline CRLF for carrots return line feed. And then the system pause is call wait message. And then my exit down here. So let me just bring that out a little bit. You don't have to, but I'm going to bring this out a little bit too so we can see the code. So what's left here are these 3 statements, and the easiest one out of all of this is this one, where we're just going to take and we're going to add, and we're going to take value and we're going to add 3 to it. That was pretty simple. And for this one's actually, pretty much all of these are mostly simple at this point. And so what I can do here for this cout is to do, getting used to the Irvine library again, move a space into the AL register, and then call write character. That covers that line of code. This covers that. So the last thing to do here is to print value. And to use the the function that I want to be able to use call write int. To be able to do that, I have to move the value I want to print into the EAX register. So I would move into the EAX register whatever value is. And let me just make this easy. Let me just put the curly brace on this line. Break my own, just so you can see kind of how the code works here and see a little bit better what's going on. And now let's see what happens when I run this. And there are my values: 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Exactly what I'm supposed to be getting. and this is where we get the 1-to-1 ratio. It only works for assembly language to machine language. You can see here that doing something like this takes 2 lines of machine language to work. And if we didn't, and even with this write int function, it's probably, it's maybe, or it probably is more than 1 line of code because it is in a library somewhere. So at the very least, this 1 line of code is 2 lines, possibly even many, many more, depending on what this function actually does. Same with write character, same with wait message, same with CRLF. There are things going on in libraries that, of course, it takes more than 1 line of code to work out. But one line of code to many, and then, whatever the 1 is to 1 when it comes to moving from C++ to assembly, and then from assembly into machine language. So that's how to do this example number 1. So as always, if you have any questions, please comment below or email me at swardb@cod.edu, and I'll get back to you as soon as I can about that. So I'm going to get on to the second problem right now in my future, and hope to see you there. It's a little more complicated than this one, and I'm going to help you through it. So as always, take it easy, everybody. Take it easy, and have a good day. See you then.